Okay, so we have studied about the working of the rapid sand filters and slow sand filters. So now we need to study some of the important features of the slow sand filters and rapid sand filters. Okay, so we have also done a problem on slow sand filters. Now we'll study the features about the rapid sand filters and slow sand filters. Okay, so we'll continue with the rapid sand filters. Okay, first we'll start with the rapid sand filters. Okay, so as we have discussed before, rapid sand filters, we have discussed the working of the rapid sand filters. Okay, so rapid sand filters is mainly used for large towns. That is, it is having a high filtration rate and it can also remove a turbidity up to 30 to 40 mg per liters. Okay, so one disadvantage of rapid sand filters is that it cannot remove bacteria efficiently as slow sand filters. Okay, it can remove bacteria only up to 80 to 90 percentage. Okay, so we have covered all these portions. This is the basic construction of a rapid sand filters. Okay, so it will be like this. The basic in ഇതുപോലെ tanks ആയിട്ടായിരിക്കും rapid sand filters ഉണ്ടാവുക. Okay, filter units will be there. Okay, so each filter units will be having around 10 to 80 meters square. Okay, now filter in each filter units will be having a filter media also. Okay, so these are the basic. It is a filter media means basically it consists of sand and gravel. Then we are having an under drainage system, that is to collect the filtered water and also to clean the filter bed using the backwashing. Okay, so these are the lateral manifolds and main drains, lateral drains. All these things we have discussed. Now this is a wash water trough. Okay, so wash water trough means the rapid sand filter. This is a wash water trough. Okay, so this wash water trough is provided to collect the dirty water after backwashing. Okay, so once it is cleaned or during the cleaning process through backwashing. അപ്പോൾ ക്ലീനിങ് നടക്കുന്നത് എങ്ങനെയാ? ബാക്ക്വാഷിങ്ങിലൂടെയാണ് ക്ലീനിങ് നടക്കുന്നത്. Okay, through the cleaning, during the cleaning through backwashing, there will be a lot of dirty water over here. Okay, so all this dirty water will be collected through this wash water trough. Okay, so this wash water trough, it can be of different shape and mainly it will be having a discharge of 1.376 by 3 by 2 y raised to 3 by 2. Okay, now it is also having an air compressor and also rate controller. Okay, that also I have discussed in last class. I have shown you a video of the air compressor, that is mainly to agitate the filter bed, അതായത് filter bed നെ ഇളക്കി വിടാൻ വേണ്ടിയിട്ട്. Okay, then the venturimeter will be there. Then the working of rapid sand filters, that also we have discussed. Next is cleaning. Okay, so cleaning is mainly done through backwashing. Okay, cleaning is mainly done to backwashing. Okay, so wash water and the compressed air is sent up back upwards of filter bed, and this will agitate the sand particles to remove the impurities. Likewise, we have discussed. Okay, അതായത് എല്ലാം തിരിച്ചു വിടും and it will be agitating the filter bed. Okay, so the entire process of backwashing will be taking around 15 minutes. Okay, so the entire process of this backwashing will be taking around 15 minutes. Okay, now we'll continue with the backwashing. Now, amount of water to be backwashed is 2 to 5% of total filtered water. Rather, for example, if 1,000 liters of water ആണ് നമ്മൾ filter ചെയ്യുന്നുണ്ടെങ്കിൽ അതിന്റെ 2 to 5% of water will be taken for the backwashing. Okay, so how much amount of water you are taking? അതിന്റെ ഒരു 2 to 5% of water, 2 to 5% of filter water will be channeled back for the backwashing. Okay, now the rapid sand filter has to be washed every 24 to 48 hours. Okay, so it's very important that here the cleaning process is very acute, so it has to be washed for every 24 to 48 hours. Okay, now the rate of washing is between 15 to 90 centimeter per minute. Okay, and the pressure of washing is 40 kilonewton per meter square. Okay, the pressure for washing is 40 kilo. That means the pressure that is induced during this washing is 40 kilonewton per meter square, and rate of washing is 15 to 90 centimeter per minute. Next one is surface wash. So the clean filtered water is applied to the sand bed from above using the nozzle. Okay, it score the particles and clean the surface. Okay, so apart from this, after this backwashing, you will be also washing the surface also. Okay, the surface will be also cleaned. Okay, so how is it is done? The clean filtered water will be applied to the sand but from above using nozzle. അതായത് നോസിൽ വെച്ച് നമ്മൾ ഫുൾ ബാക്ക് വാഷിങ് കഴിഞ്ഞതിന് ശേഷം നോസിൽ വെച്ച് നമ്മൾ മുകളിലൂടെ വെള്ളം കടത്തി വിടും. Okay, so what will happen? So it will score and clean all the particles in the filter bed. Okay, so after the back washing, you will allow the clean filtered water to pass through the filter bed from above, from top. മുകളിൽ നിന്നായിരിക്കും നമ്മൾ പാസ് ചെയ്യുക. Okay, so it will score all the particles and clean the surface. So that is called as surface wash. Okay, now we are facing certain difficulties during the running of this rapid sand filters. Okay, rapid sand filters in the working the സമയത്ത് there are certain difficulties. Mainly we will be facing three types of operational troubles. That is, air binding can occur, formation of mud balls can occur, and cracking of filter can occur. Okay, so these are the three operational troubles that occurs in the working of a rapid sand filters. So we'll see in this details what is all these three means. First one, coming to the air binding. Okay, air binding. So air binding means when the head loss due to clogging, there will be the head loss due to when the head loss due to clogging occurs, there will be a negative pressure. Okay, this results in releasing of dissolved air in the water and cause the formation of air bubbles. Okay, and these bubbles stick to the sand grains and affect the working of the filter badly, and this can also decrease the rate of filtration. Okay, so what do you mean by air binding? Air binding എന്ന് വെച്ച് കഴിഞ്ഞാല് there will be always a head loss. Okay, there will be always a head loss in the filters. Okay, so when there is a head loss means level difference between the water. Head loss ഉദ്ദേശിക്കുന്നത് level difference between the water. Okay, so whenever there is a head loss in the rapid sand filters, the clogging will be there will a negative pressure will be developing. Okay, whenever there is a head loss in the rapid sand filter, there will be a negative pressure. Okay, so this negative pressure will result in the release of the dissolved air in the water. Okay, and this will cause the formation of air bubbles. Okay, and what will happen, these air bubbles will stick around the sand grains. ഈ air bubbles എല്ലാം കൂടെ എന്ത് ചെയ്യും, sand grains ന്റെ ചുറ്റും ഇങ്ങനെ ഒട്ടിപ്പിടിച്ചിരിക്കും. Okay, and it will affect the filter working of the filter bed badly. അതായത് സാൻഡ് ഗ്രെയിൻസിൽ ഇങ്ങനെ ചുറ്റി പിടിക്കുമ്പോൾ എന്താ ഫിൽറ്റർ ബെഡ് സാൻഡ് ഗ്രെയിൻസ് മീൻസ് വാട്ട്, ദേ ആർ ഫിൽറ്റർ ബെഡ്. സാൻഡ് ഗ്രെയിൻസ് ഇസ് എ പാർട്ട് ഓഫ് ഫിൽറ്റർ ബെഡ്. ഓക്കെ, അപ്പൊ ഫിൽറ്റർ ബെഡിന്റെ വർക്കിങ്ങിനെ ആയിരിക്കും അത് ബാധിക്കുക. സോ വാട്ട് വിൽ ഹാപ്പൻ, ഇറ്റ് വിൽ റെഡ്യൂസ് the rate of filtration. It will reduce the rate of filtration. That means the rate of filtration will be reduced. That is, the filter ബെഡിന്റെ ചുറ്റും ഇങ്ങനെ ഈ ബബിൾസ് ഇങ്ങനെ ഒട്ടിപ്പിടിച്ചേക്കും, അല്ലെങ്കിൽ ബബിൾസ് ഇങ്ങനെ പറ്റിപ്പിടിച്ചിരിക്കും. ബിക്കോസ് ഓഫ് ദാറ്റ് the proper filtration won't occur. Due to this reason, the proper filtration won't occur. Okay, so I'll show you a small video of the air binding, how it looks like. See here. See, you can see അതുപോലെ ഡിസോൾഡ് ഗ്യാസ് പൊന്തി പൊന്തി വരും. You can see from this video. You can see. Okay, see, because of that negative pressure, there will be a dissolved gas like this. Okay, so because of this dissolved gases, അതെല്ലാം കൂടെ ഫിൽറ്റർ ബെഡ്, അത് സാൻഡ് ഗ്രെയിൻസിൽ പോയിട്ട് ഈ ബബിൾസ് ഒക്കെ പറ്റി പിടിച്ചിരിക്കും. So because of that, the filtration will be reducing. Rate of filtration will reduce. Now, how can we avoid this air binding? Okay, first of all is that you have to avoid the head loss. Okay, you have to avoid the situation that lead to head loss. Second one is you have to control the growth of algae. If there is a lot of algae also, the clogging will occur, and thereby the dissolved gases the air head loss can occur, and the dissolved gases will be appearing more. Okay, so you have to control the growth of algae. Third one is that super saturate water with air. Okay, you should always saturate the water with the air. Okay, so that you can reduce the dissolved gas content. Fourth one is that prevent the water getting warmed. Okay, the warm water also will be giving a lot of bubbles. Okay, when the water is too warm, it will, when it is flowing, when the water is too warm and during its flowing, it will also lead to the formation of a lot of bubbles. Okay, so when the lot of bubbles are forming, it will stick around the filter bed. Okay, so these are the four remedial measures that you can take to avoid the air binding. First one is that you can avoid the head loss. You should control the growth of algae. You should saturate the water with air and also prevent the water getting warmed. Okay, that is when it should not be exposed to too much of hot temperature. Second operational troubles of rapid sand filters is that there is a formation of mud balls. Okay, the mud balls can be formed. Okay. So, what do you mean by mud balls? We all have seen mud balls, and then mud balls on a okay. That means mud from the atmosphere will accumulate on the sand surface. Okay, so during the inadequate washing, this mud will sink down into the filter bed, and mud sticks to the sand grains and form mud balls. Their size go on increase, and it affect the filtration and back washing. Okay, so and then mud balls means in atmosphere always there will be always a small fine particles. Okay, small fine ആയിട്ടുള്ള ചെറിയ ചെറിയ തരിമണലൊക്കെ ഉണ്ടാവും. Okay, so our filter bed is having a certain size. All the materials in our filter media is having a particular size. Okay, so in the atmosphere, you have seen the rapid sand filters, they are exposed to the atmosphere. We are not closing it, it is exposed to the atmosphere. Okay, so in the atmosphere, there will be always small mud particles. Okay, so these mud particles will accumulate on the filter bed. These mud particles will accumulate in the filter bed. Okay, so because of the inadequate washing, these mud balls will sink down to the filter bed. അതായത് വാഷിംഗ് പ്രോപ്പർ അല്ലെങ്കിൽ ഈ മഡ് കുറച്ചുകൂടെ താഴത്തേക്ക് പോകും, ഫിൽറ്റർ ബെഡിന് താഴത്തേക്ക് പോകും. Okay, and there what will happen, more and more mud balls will be coming and it will form into a bigger size. Okay, more muds will be coming. അത് കുറെ മണലുകളൊക്കെ വരുമ്പോൾ its size will be increasing and it will be lead to the formation of a mud ball. Okay, so this will be trapped between the voids of the filter bed and it will affect the filtration and backwashing. ചെറിയ ചെറിയ മണലുകൾ ഈ ഫിൽറ്റർ ബെഡിന്റെ ഇടയിൽ തങ്ങി നിൽക്കും. ഓക്കെ, ബിക്കോസ് ഓഫ് ദ ഇന്നോഡിക്കേറ്റ് വാഷിംഗ് ദീസ് സാൻഡ് പാർട്ടിക്കിൾസ് വിൽ സിങ്ക് ഡൗൺ. ഓക്കെ, ആൻഡ് അവിടെ വേറെയും കുറെ സാൻഡ് പാർട്ടിക്കിൾസ് എല്ലാവരും കൂടെ ഒരുമിച്ച് വന്നിട്ട് ഇറ്റ് വിൽ ഫോം എ ബിഗ് മഡ് ബോൾ. ഓക്കെ, സോ അത് ഇറ്റ് വിൽ ബി ട്രാപ്ഡ് ബിറ്റ്വീൻ ദ voids of the filter media and it will affect the rate of filtration and backwashing. That is called as formation of mud balls. So how can we reduce, or what is the remedial measure for this mud balls? First one is you can break whenever you see a mud ball, break it immediately. Okay, break it immediately. You can break it by mechanical mode, you can also break it by water nozzle. അത് വെള്ളം നന്നായിട്ട് അടിച്ചു കൊടുക്കുക, so it will break. Okay, next one is you should use compressed air to score the mud ball. Okay, you should also allow the compressed air to pass through it so that mud balls will be breaking. So another remedial measure is that you can apply caustic soda. Okay, also you apply caustic soda, it will break. Or you should replace the filter bed. Okay, whenever you see any type of mud balls that is trapped between the filter media, it's you can replace the filter bed. Okay, you can replace the filter bed. Okay, so mainly 5 remedial measures are there. What are they? First one is whenever you see a mud balls, you should break it immediately. You can break it in the mechanical mode or you can spray water through nozzle. വെള്ളം അടിച്ചു കൊടുക്കുക. Next one is you should use compressed air. You can apply caustic soda and you should replace the filter bed. Okay, so these are the 5 measures that can be taken to reduce the formation of a mud ball. Coming to the third one, that is a cracking of filter. From the name itself, we can understand what you mean by cracking of a filter. Okay, let's see what it is. The fine sand on the top layer shrink and cause shrinkage crack. Impurities sink down directly through this crack and affect the efficiency of the filter. That means here what is happening? The filter bed is cracking. Okay, so here the filter bed is cracking. So how the filter bed is cracking means the fine sand will accumulate on the top surface. Okay, fine sand will be accumulating on the top surface because water will be having a lot of fine particles. Okay, so these fine particles will be accumulating on the top and it will cause a shrinkage, and this will lead to a shrinkage crack. Okay, so when there is a crack is formed, so when now that a crack is formed, the impurities will sink down through this crack. The crack form ചെയ്ത് കഴിഞ്ഞാൽ impurities ഒക്കെ എന്ത് ചെയ്യും ക്രാക്കിലൂടെ താഴേക്ക് പോകും. Okay, so this will affect the efficiency of filter. Okay, this will affect the efficiency of filter. Coming to the design criteria of the rapids and filters. Okay, so first one coming to the filter tank. Okay, so area of the filter bed is taken as discharge divided by rate of filtration. Okay, now the filtration rate is taken as 3000 to 6000 liters per hour per meter square, and if you convert it to meter cube, 3 to 6 meter cube per hour per meter square. Okay. Now coming to the design of the under drainage system. Okay, so under drainage system then mainly it consists of manifolds and perforated pipes. Manifolds and perforated pipes. Okay. The total cross-sectional area of this perforation is taken as 0.2 percentage of the filter area. The perforations in the area that is 0.2 percentage of the total filter area. Next is coming to the cross-sectional area of the each laterals. You have seen laterals, right? So each laterals in the area is equal to 2 to 4 times of area of perforations. One laterals in the area 2 to 4 times of area of perforations. Now cross-sectional area of manifold is taken as 2 to 2 times that of laterals. Okay. So your bottom portion of the tank. Okay, so this is the manifolds. So ഇതാണ് manifolds and this is the laterals. ഇങ്ങനെയാണ് laterals ഉണ്ടാവുക. So this will be at the bottom portion. Okay, so this cross section, this is the manifold. Okay, so cross section of the manifold is taken as 2 to 2 times that of laterals, and this is the laterals. Okay, laterals laterals in the area is taken as 2 to 4 times the area of perforations. Okay, so all these things we have discussed. A manifold and the laterals and the perforations ഒക്കെ നമ്മൾ ലാസ്റ്റ് ക്ലാസ്സിൽ ഡിസ്കസ് ചെയ്തതാണ്. So I'm not going to that detail. The maximum permissible velocity in the manifold is 1 to 2.4 meter per second for the wash water. Okay, so that is for the backwashing. The maximum permissible velocity of water in the manifold through the manifold. Okay, maximum permissible velocity through the manifold is 1.8 to 2.4 meter per second for backwashing. Backwashing വേണ്ടിയിട്ട് നമ്മൾ കൊടുക്കുന്ന maximum permissible velocity through manifold is 1.8 to 2.4 meter per second. Coming to the design of a wash water trough. Okay, so wash water trough, it is kept at a spacing of 1.1 to 2 meters. Okay, it is kept at a spacing of 1.1 to 2, or a filter bed below. It is kept at a spacing of 1.1 to 2 meters, and the number of units എത്ര wash water കൊടുക്കണം എന്നുള്ളത് determine ചെയ്യുന്ന width of the filter divided by spacing of the trough. Okay, so if you divide the width of the filter with the spacing of the trough, you will get number of units. എത്ര number of units? Lot of amount of water has to be removed. Okay, so one wash water trough is not enough anyhow. In one unit, one wash water trough is not enough. Okay, so this is you might have been remembering. So this is wash water trough. See, this is wash water trough. Okay, but ഇതുപോലുള്ള one unit is not enough. Okay, one unit is not enough. You have to provide 2 or 3 wash water trough, because lot of water has to be removed. A lot of amount of water has to be removed. So the number of wash water trough, how will you obtain the number of wash water trough? That is by dividing width of the filter with the spacing. Okay, now discharge, already we have discussed 1.376 b by 3 by 2. So b is a width and y is a depth of water. Okay, width of the wash water trough is assumed to be equal to the depth of the trough. Okay, so for the trough, okay, wash water trough, the depth width equal ആണ്. Okay, for the wash water trough, the depth and width is almost equal. Rate of washing is around 15 to 90 centimeter per minute. Okay, the rate of washing is around 15 to 90 centimeter per minute. Now discharge is equal to rate of washing into area of filter. Okay, wash water discharge is equal to rate of washing into area of filter. You will get the discharge, wash water discharge. Okay, so there is a problem. I think problem we can do in the class. Okay, now coming to slow sand filters. Okay, so we have not discussed the advantages and disadvantages of slow sand filters. So you remember what is slow sand filters? So we have discussed the working of slow sand filters. Okay, so slow sand filter basically a quick revision. It will be having a filter bed. Water will be passing through the filter bed, and at the bottom portion we will be providing lateral drains. So the water will be collected to the lateral drains, from the lateral drains to the main drains, and from the main drains it will be taken to the distribution chamber, whatever it is. Okay, so that is a slow sand filters. Okay, so this is you can say. Now, one of the disadvantages of slow sand filter is that you cannot take water after sedimentation coagulation. Okay. To the slow sand filter, water has to be supplied from the plain sedimentation tank. Okay. To the slow sand filter, water has to be supplied from the plain sedimentation tank. Plain sedimentation tank in the slow sand filter like okay. You cannot take water from the coagulation sedimentation tank. Okay. So it is one of the disadvantages of slow sand filter, but at the same time, here the bacterial removal efficiency is very high. That is around 98 to 99% of bacteria can be removed in the slow sand filters. So we have discussed coming to construction, that is it is having an enclosure tank. Mostly it will be having a rectangular shape, depth of 2.5 to 3.5 meters, plan area is 100 to 200 meters square. It is having a filter bed, that means top portion will be having sand and the bottom portion will be having a gravel. Okay, so gravel mainly it will be having a thickness of 70 to 30 to 75 centimeters. So gravel അതായത് മൂന്നോ നാലോ ലെയറിലായിരിക്കും gravel ഇടുക, and each layer will be having 15 to 20 centimeter thick. Okay, total thickness of this gravel layer will be 30 to 75 centimeter. Total thickness of this gravel is 30 to 75 centimeter. Okay. Now coming to the under drainage system. So mainly it is having a central drain and main drain. The central drain is also called as main drain. Okay, so it's lateral central drain and lateral drain. Okay, so central drain is also called as main drain. So lateral drain, they are open jointed or a porous drain. It will collect the filtered water to the filtered water and discharge into the main drain. Lateral drain it will be a porous drain. Okay, ഒരു ഓപ്പൺ ആയിട്ടുള്ള ഒരു porous drain ആയിരിക്കും. It will be taking water to the main drains. It will be taking water to the main drains. From the figure itself, you can see this is the lateral drains. See, so this is the lateral drains. Okay, so this will be taking water to the main drains. പിന്നെ ഇൻലെറ്റ് and outlet arrangements. Inlet എന്ന് പറയുമ്പോൾ water to admit water into the filter bed. Outlet that is mainly to control the discharge. Mainly to discharge the filtered water. Outlet mainly to discharge the filtered water. Okay, so this Lausanne filter we are fitting a telescopic tube. An instrument called as telescopic tube is fitted. That is mainly to control a constant discharge. അല്ലെങ്കിൽ you can say to maintain a constant discharge. എപ്പോഴും ഒരു constant discharge maintain ചെയ്യാൻ വേണ്ടിയിട്ട് you are providing a telescopic tube in the outlet unit. So it is having an inlet unit and also an outlet unit. Inlet എന്ന് പറയുമ്പോൾ വാട്ടറിനെ ഫിൽറ്റർ ബെഡിലേക്ക് അഡ്മിറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ടുള്ള യൂണിറ്റ് is called as inlet chamber. Working as Lausanne filters, this we have discussed. Okay. Cleaning, that also we have discussed. So cleaning ഇവിടെ വേറെ techniques ഒന്നുമില്ല, you're just scraping it. Okay. And this Lausanne HAP filter has to be cleaned in 1 to 3 months. Okay, coming to the uses. Uses it is mainly used for small plants. Okay, Lausanne filter is mainly used for small plants, and it is used for the water with a low color and low turbidity. Okay, that കുറച്ച് ചെറിയ കളറും ചെറിയ turbidity ഉള്ള വെള്ളത്തിലേക്കാണ് you should be using Lausanne filters. Okay, it requires huge area and huge quantity of filtering materials and huge space. Okay, so this Lausanne filters it requires a huge area, a large amount of filtering materials, and also it requires a huge space. Okay, now advantages of this Lausanne filter is that it is very simple to construct and operate. The operation is very simple, and also construction procedure is also very simple. It is very cheap, and the physical, chemical, and bacteriological quality of the water is very high. Okay, so water which is filtered from the Lausanne filter will be having a high physical, chemical, and bacteriological purity. Okay, that bacteria purity വളരെ കൂടുതലായിരിക്കും. 98 to 99% ആണ് അതിന്റെ റിമൂവൽ. Okay. So we can ensure that the filtered water from this Lausanne filter will be having very good physical, chemical, and bacteriological purity. Okay. It also reduces the bacterial count by 99.9% and E. coli by 99%. Now disadvantages. So what is the disadvantage of Lausanne filter? It is very old-fashioned and outdated method of water purification, but people are still using it. Okay, it is a very old-fashioned method. വളരെ പഴയ method ആണ്. It is also an outdated technique, but people are still using it. Now, initial cost is very low, but the maintenance cost is very high. That is, even it is more than rapids and filters. Okay, so its maintenance is very difficult. Okay, and the filters requires a lot of space. That is, it requires a huge amount of space. Okay, so that's one three disadvantages of slow sand filters. എന്തൊക്കെയാണ്? It is an outdated method. Second one is that its maintenance cost is very high, that is even higher than rapid sand filters. And third one is it requires a lot of space. Okay, so that's about the features of slow sand filters and rapid sand filters. Okay, so today we'll go learn about a new technique. Sorry, new technical. The പുതിയ filters, that is pressure filters. Mhm. Okay, so we have learned about two types of filters in this module, that is slow sand filters, so rapid sand filters. Okay, so we'll also study last filter for this module, that is pressure filter. Okay, or filter കൂടെ പഠിക്കാനുണ്ട്, that is pressure filter. So from the name itself we can understand that it is somewhat related to pressure. Okay, so what do you mean by pressure filter? So pressure filter, so it is a filter which is placed in a closed vessel and water pass under pressure. Okay, its rate of filtration is very high, that is around 6,000 to 15,000 liters per hour per meter square. It is less efficient and produce pure quality of effluent. It is not used for the public supplies. It is used for the individual industries, swimming pools, etc. And it is very compact and easy to handle. Okay. So pressure filters is a filter which is placed in a closed vessel. So you can say this pressure filter in a closed vessel. Okay. And here the water will be passing under pressure. So another advantage of pressure filter is that its a here rate of filtration is very high. That is around 6,000 to 15,000 liters per hour per meter square. So if you go to rapids and filters, there 3,000 to 6,000 are no rate of filtration. Slow sand filter is even less. Okay, slow sand filter അതിലും ചെറുതാണ്. Okay, so coming to pressure filters, it is high. That is 6,000 to 15,000 liters per hour per meter square. That's a rate of filtration. Okay, so its rate of filtration, the amount of water that can be filtered is very high. But another disadvantage of this pressure filter is that it won't give you a clean effluent. The effluent that is produced will be of very poor quality. So because of this reason, it cannot be used for the public supplies. It can be used for the individual purpose, or it can be also used for the industries. Okay, so industries like effluence in the quality is not much important. That means it should not contain any kind of toxic materials. In the industrial effluence, it should not have much toxic materials. Okay, so it cannot be used for to supply water to a large towns or a small towns. It can be used for the individual purpose. It can use industries also, you can use, and can be also used for cleaning the swimming pools. Okay, it can be also used for cleaning the swimming pools. So it is very compact and very easy to handle. Okay, if you go to the construction details, so this is the construction details. Okay, so basically it consists of a steel cylinder. It is having a 1.5 to 3 meters of diameter, and it is having a length of 3.5 to 8 meter. Okay, having inspection windows at the top. So top pillar, you can see here, this is the inspection walls, inspection window, sorry. Okay, top pillar, it will be having inspection windows. Okay, so the pressure filter അത് basically ഒരു cylinder shape ആയിരിക്കും. Okay, the pressure filter basically it will be having a cylinder shape, and its diameter will be around 1.5 to 3 meters, and its length will be 3.5 to 8 meters, and there will be an inspection windows on the top. Okay, so it can be installed horizontal, or it can be also installed vertical. That depends upon the customer choice. So this is a horizontal pressure filter. I think നേരെയും വെക്കാം, vertical ആയിട്ടും വെക്കാം. Sorry, this is a horizontal pressure filter. Okay, ഇതൊരു horizontal ആയിട്ട് വെച്ചിട്ടുള്ള pressure filter ആണ്. Okay, this is a horizontal pressure filter, and this is a vertical pressure filter. Okay, so this is a vertical pressure filter. So the vertical at which it is called as a vertical pressure filter. The previous you can see it is kept horizontal. Okay, then horizontal at use. If it is kept horizontal, it will be having horizontal pressure filter. If it is kept vertical, it is having vertical pressure filter. Okay, so the ingredients are basically same. The ingredients are basically same. I'm going to complicate it. നേരത്തെ നമ്മൾ ഡിസ്കസ് ചെയ്ത പോലത്തെ സ്ലോ സാൻഡ് ഫിൽറ്ററിലുള്ള പോലെ തന്നെ it will be having a filter bed. Okay, it will be water will be allowed through the top, and it will be collected at the bottom after filtration. Okay, we'll see the working. So working means the coagulated but not flocculated water is used. The flocculation takes place inside the filter, and water enters to the sandbed under pressure and pass through the gravels and reaches the gravel laterals, and from the laterals it is taken outside. Okay, how we are cleaning means it is cleaned by backwashing. Okay, so this portion we can discuss tomorrow. For now, I think it's enough. You can post your name to mark the attendance.